Welcome back. We now look at the operational definition of the work interaction. This is the proper thermodynamic definition of work. We ask ourselves this question. Since thermodynamics requires that work as an interaction must take place between two systems, let's consider two systems, a system A and a system B. I am showing them apart just for clarity. Let this be the boundary between them and let there be some interaction I between the systems A and B. This is, let's say, the way we have shown the direction, the interaction from system A to system B. Because of this interaction, the state of system A will change, and let the initial state of A be A1 and let its final state be A2. Because of this interaction, the state of system B will also change. Let B1 be its initial state and B2 be its final state. The question which we now ask ourselves is the interaction I, the work type of interaction from the thermodynamics point of view. So here we want an answer yes or no. Particularly, we look at cases where the answer is a resounding yes, because if work interaction is mixed up with some other type of interaction, then the answer would definitely be no. And if the answer is yes, if I is purely a work interaction, what is its direction and what is its magnitude? The operational definition follows a few steps. Notice that the requirement is that the interaction should lead to nothing but the raise of a weight. So, in the first step, what we try to do is the following. We have our system A, we let it undergo the same interaction. Let it behave as if it is interacting with system B and the interaction is I as required. So, nothing changes from the point of view of system A. However, we try to replace system B by another system. You may call it even a contraption, but nevertheless it is a thermodynamic system. C1, we try to discover, invent such a system whose final result would be nothing but raise of a weight. And that means let it raise a mass m1 in a gravitational field g up by a height say h1. The requirement on C1 is that it must be a primitive system defined using principles in other branches of physics. It must be fully defined, no black boxes will work, and there should be no change in the state of C1. This is also very important. That means C1 can undergo a cycle, can execute a cycle, or it need not execute any process, it executes no process. Actually, no process is an extreme example of a cycle. The initial condition and the final condition are unchanged, the same, and there is no process involved at all. The system does not even move from its initial state. Notice that the required thing is the raise of a weight. A lowering will not do. It has to go up like this. Okay. Now, it is possible that we are able to set up C1. So, we come to now the first conclusion. If C1 can be set up as required, then we make the following conclusions. First conclusion is I is work and nothing else, purely work. B, the quantitative, we say work done by system A is plus M1 G H1. This will be a positive number. Work done by system B will be minus M1 G H1. This will be a negative quantity. And third thing we say is system A does work on system B. But it is possible that we are not able to set up this required system C1, and the conclusion is possible only if we can set up C1. So it is possible that C1 cannot be set up. So the next step is, if C1 cannot be set up as specified, then we go to step 2. Now here what we do is the following. We leave system B undisturbed. It behaves as if A is interacting with it and the interaction is I. As before, it undergoes the change of state from B1 to B2. So nothing changes from its point of view. However, now we replace A by a system which would do the following. Let us call this system C2 and we check whether such a system can be set up. First, C2 as required for C1 should be made up of primitive mechanisms and it should undergo no net change in same conditions which we put on C1. The net effect of replacing A by C2 is that some mass, say M2, in a gravitational field G should be raised, mind you, raised, not lowered, by a height h2. Again, let me emphasize that raise is important. And now we conclude that if C2 can be set up, then A, the interaction I is work. B, work done by system B is plus M2G H2, which will be a positive number, and work done by system A is minus M2G H2, which is a negative number. And we say finally system B does work on system A. Conclusions are similar to the conclusions of step 1, but the other way, A and B get interchanged, and of course 1 and 2 get interchanged. It is also possible that we cannot set up C1 nor can we set up C2 as required. Then the conclusion is the interaction I is not completely a work interaction. It may be work in part, but definitely there is a component which is the non-work type of interaction. Later on we will define this non-work type of interaction as the heat interaction. Thank you.